And distillation is used to separate miscible liquid and is based on difference in boiling point. If you have two miscible liquids that have widely, unduly far apart boiling points, then we can use simple distillation to separate such liquid. A good example is a mixture of ethanol and water. Ethanol and water are miscible liquid, that is, you can mix them and they mix completely. I wrote ether instead of ethanol. Wonderful. Let me write that. Ethanol and water. They are what? Two examples of miscible liquid. Miscible liquid are liquid that are mixed together completely. When you pour ethanol into water, both of them will mix completely in a way that one will not be able to distinguish one from the other. Those type of liquid are called miscible liquid. So if the boiling point of the two liquids are far apart, then we can use distillation to separate them. For example, the boiling point of ethanol is 78 degrees Celsius, while that of water is 100 degrees Celsius. So to separate these type of liquid from each other, we can use distillation. Using the distillation apparatus, which is a setup like this: a round bottom flask, a source of heat, and a stand, a condenser. This condenser, you can see there's a pipe inside, then there's a pipe outside. The outer pipe is designed in a way that you can pass an inlet. This is an inlet that allow cool water to go into this place. As the cool water goes into this place, it cools the inner pipe. As it cools the inner pipe, the water comes out here. So as we boil the mixture, here's the mixture here. As we boil the mixture, because when boiling takes place, whatever is here will turn to vapor. Whatever is here will turn to vapor. So that the gas will come pass through this pipe, inner pipe. Now, when it gets into this condenser, because of this cool water that is being passed into the condenser, the gas will turn to liquid, and then the liquid will come out in this container. Now, we said that we use it based on boiling point. So for ethanol and water, they have different boiling points. If we apply it here, ethanol will boil first because it has a lower boiling point. So whatever is coming out at a temperature between or from 78 degrees downward, anything that comes out here is definitely ethanol. So the temperature is 78 degrees. So as it boils, it turns to gas and comes out through this pipe. And then it's collected in this container, which we call the distillate. That is, whatever is collected here is called the distillate. Once all the ethanol boils off, then you can remove this distillate and then use another container to collect the water if you're interested in collecting the water or whatever is left behind. Now, where the temperature or where the boiling point is close, then we can't use simple distillation. Rather, we use fractional distillation. And then the difference between simple distillation and fractional distillation is that a fractional distillation contains a fractionating column. A fractionating column, the one we use in the lab, just a special container that is filled with pieces of glass here, pieces of glass. Now this fractionating column is attached to this container here, this round bottom flask. So attached to it, such that the vapor that is coming out of this place, first of all, goes through the fractionating column before coming into the condenser. So as it goes into the fractionating column, the temperature there is lower than the temperature of the container. And so, because this liquid boiling point that are close, as this one at 78 degree boil, it could be that a little of this will also boil and goes into the fractionating column. But because the temperature in the fractionating column is lower than the temperature in the container, and the boiling point of this is not yet reached. So once it gets into the fractionating column, it turns back into liquid and falls back into the container. While the one that the boiling point is already reached, it goes into the condenser and then comes out as a distillate. Let's go and watch the simulation of that. So first of all, simple distillation. Okay, here's the mixture to be separated in this round bottom flask. Then you can see a thermometer attached to the round bottom flask. The thermometer is to read the boiling point of the mixture, the component of the mixture. So in this case, Let's assume this is a mixture of ethanol and water. So the moment we heat it up, because the boiling point of ethanol is lower than the boiling point of water, the ethanol will boil first. So as it boils and turns into vapor, the vapor will go through this condenser. As it enters into the condenser, cool water is coming in and turns back into liquid and is collected as a distillate in this conical flask. Let's watch and see what happens. You can see the mixture is boiling, you can see gas is rising up, and you see the gas represented with this arrowhead. Now you can see the distillate is coming out in this conical flask. So this will continue until all the ethanol in this container boils, and you can, of course, look at the temperature. Anything that is coming out from a temperature of 78 degrees is definitely ethanol, because the temperature of the boiling point of ethanol is lower than that of water. So once the temperature, as long as the boiling point, or the temperature rather, as long as it remains at 78 degrees, anything that is coming out here is ethanol. Simple distillation in action. The mixture here in the round bottom flask, and here is a fire burning to boil off the mixture. As it boils, the one with lower temperature turns to vapor, and you can see the gas that is coming out, and the gas gets into the condenser. It turns to liquid and flow into this conical flask. Let's see that in action again. Now the mixture is boiling and turning into gas. The one with lower boiling point is the one boiling right now. It turns into gas and is then goes into the condenser, turns back into liquid, and then is collected in this conical flask. This one that is collected here in the conical flask is called a distillate. Okay, so that is simple distillation. Now let's look at fractional distillation. Like I said, the difference between the two is that simple distillation is used for separating liquid that, if the boiling point are not far apart, we use fractional distillation. The fractional distillation contains the apparatus has a fractionating column. So let's look for that fractional distillation. Okay, here is a setup of fractional distillation. You can see there's a fractionating column here. This thing here on top, and the fractionating column is filled with pieces of glass. So the temperature in the fractionating column is lower than the temperature in the container. So if the boiling point of the liquid is close, then as one of the liquid boils, the one with lower boiling point, as it boils, part of the other liquid may also goes into vapor and then comes into the fractionating column. But because the boiling point is not yet reached, as it comes into the fractionating column, it will turn back to liquid because the temperature in the fractionating column is lower than the temperature in the container. So it turns back into liquid and go back into the container. While the one with lower boiling point will go into the condenser and be collected as a distillate. So let's watch. You see that something is falling back into the container. That is a depiction of a little of the particles or the second liquid that went into the fraction. The boiling point is not yet reached. As it gets into the fractionating column, it falls back into the container. While the other one with lower boiling point still continues its journey as gas and eventually gets into the condenser, then turn to liquid inside the condenser and falls into the conical flask to be collected as a distillate. So that is fractional distillation in action. We use it to separate miscible liquid that have close boiling points, while simple distillation is used to separate miscible liquid that have far boiling point. Okay, this fractionating column and fractional distillation rather is what is used in the industry to separate crude oil. And we have several components. You have petrol, you have kerosene, you have diesel, or lubricating oil. All of these are components of crude oil. Now, these components are separated using fractional distillation. But the boiling point of these components are quite close to each other. You can see what is happening in fractionating column help to return a little vapor of the second liquid that goes up there when the first liquid is boiling. So when it gets into the fractionating column, it goes back because the temperature in the fractionating column is lower than the temperature in this. So there you have it, distillation and fractional distillation.